So good afternoon everyone. Today is another class of problem solving. First I introduced myself. I am Povir Maiti. I am a PMRF student of Aijar Mohali. So today I am going to discuss about some problem during the courses. The course name was the Symmetry, Stereochemistry and Application. And course instructor was Professor Ungsuman Chaudhary. So earlier classes we have told about that some problem about that UPAC name and the stereochemistry of a organic molecule and some problem about that some problem about on SN1, SN2 reaction, elimination reaction and all of this. So now in these classes we are also going to solve some problem on regarding that regarding the synthesis of a organic molecule and how their hydrolysis or how the hydrogenation reaction is going on. So this is the first problem. So we have to predict the product of the following reaction and indicate whether it is an example of stereoselective or stereospecificity reaction. So what first we have to know stereoselective and stereospecific reaction. So stereoselective reaction means where we can get only mm, one only more than one product, and out of this one product will be major and one will be the minor one. But when you are going for the stereospecific reaction, so there will be only possibility for getting only one product, not multiple product. So stereoselective reaction means where we get multiple product, but we are get one product and measure one product as minor, but stereospecific reaction there we don't get any multiple product, we are getting only one product. So now we start that little introduction about stereospecific and stereoselective reaction. Now we start the real problem of this. So the first we have to um, sorry. So first we have to going to solve this problem. So how we'll solve? So you see. So in this problem they are given that we have to find out the reaction. When we have to find out the product and we have to tell about the stereoselective reaction or stereospecific reaction. So this is a 5-member hexane type of ring. So if I ring this ring, if I modify this ring as other way, so like a chair form or board form, so what will be the ring will be like this, so ring will be like this. So I am drawing the chair form of this ring. So it will be like this. So where that at position 1 there will be, so this will be position 1, 2, 3 and this will be 4. So at one position we have the carbonyl group. Sorry. So at position 1 we have the carbonyl group and position 4 we know there will be butyl and hydrogen group. So this position there will be one carbonyl and position 4 there will be one third butyl which is the above the plane and one hydrogen which is the below the plane. And this one is the third butyl group. This will be like this. So now we know that that any LiH4 is a reducing agent. It reduces the carbonyl center to 2 degree alcohol. So this one is a one carbonyl center. So it will reduce this carbonyl center to 2 degree alcohol. But this reaction there will be two probability. So it's going to attack this carbonyl from that behind the plane or above the plane. So first, so there will be two product will be from. So one product will be like this. So where H will be above and there will be 2 degree alcohol, so only OH. And so we have the tarbutyl group. This will be our one product. And again, another one will be. The OH will be above and H will be below. So between these two products, what do you think who should be major product and what should be the minor product? So because this start butyl group are the bulkier group which are present at the above the plane. And if we place this OH which are also bulkier as compared to hydrogen, so it also in the above the plane. So both the above the plane, so there will be some interaction between this and this OH. So this will be not favor our this conformation. So the reactivity of this will be less as compared to that one. So that this will be our major product. And this one will be our minor product. So then we have to find out this one is a stereo selective reaction or stereo specific reaction. So this one is an example of stereo selective reaction because here the multiple product are formed and in between one product is major and one product is minor. So why this major and minor product is formed? Because this tert-butyl group has position in the fourth position and there will be one position, there will be some OH group. So there will be maybe the interaction between tert-butyl and OH not enough to stabilize this molecule like this way. So this will be stabilized like this way. So this will be our major product. Similarly, if we go to the next example, so we have to remove the bromine from this reaction. So is a example of stereospecific reaction. So dehalogenation reaction means so we have to remove that bromide. So now we have to go to draw this one like this. I will tell earlier that the above the plane will be left hand side and The second above the plane, so this will be like this. So second above the plane will be right hand side, but this one is left hand side. So this one is CS3. Does I draw this one is right or not? So you can also check by that RS nomenclature. So in our first carbon, the bromine is above, so the hydrogen will be below. So this will be our the first priority. This will be our second priority, and this will be our third priority, and fourth priority is below. So 1, 2, 3. This one is clockwise, like this will be R. And here this will be 1, 2, 3. Also not 3. 1, 2. This one is 2, and this one is 3. And this will be gone 1, 2, 3 anti-clockwise, and 4 priority below. So this will be R. So this will be R. This also R. Now the next carbon one. So this one will be our first priority. This one is second. This one is third. First, second, and third priority. First, second, third. It's going to clockwise, but our four priority is above, so it will be yes. So now we have to find out this one R or S. So this will be our first, this will be second, and this one is third. So first, second, three is going to clockwise. First, second, three, 1, 2, 3 is clockwise, and four priority is horizontal. So this will be yes. So it will be matching. So this one is an example of stereospecific reaction. So how this will be reaction is so dehalogenation reaction means if there will be any iodide or anything which capture this hydrogen, this will come in here, and this bromide gets. Sorry, not like this way. So there will be dehalogenation means where all the brom halides should be removed. So any dehalogenation reaction, so anything so that remove the R bromide. But this one will be transposition, so our product will be like this. So finally product we got from here, this will be like that. in one case. So if like this, so added, so this bromide. So one case hydrogen is below, and another case hydrogen is above, like this. So one case is hydrogen is below here, and one case hydrogen is above here. So we get this product. So this one, so from this reaction we get only one product. This one is E or Z. So this will be like a Z type of product, Z to butene. So this one example of stereospecific reaction. So stereospecific reaction is this reaction where the only we are getting only one product. Jet built in, or you can write to built jet, jet built to in, like that. So this one is an example of stereospecific reaction. So if you are getting some reactant will be, so if we like this reaction where the bromide is here, one case, another case here. Here also we get stereospecific reaction, but now the product will be this one is hydrogen. Now product H are all in same side. So now the product will be like this. All CH3 is above. So these are E product. So these are also stereospecific reaction, but from this we get E product, but from there we get Z product. So this will be, if we draw like this, all the bromide will be in the above. So in all of the cases, the hydrogen will be below. Now the next example one. This is an example where we have given in that reaction KOH ETOH. So it will be like one elimination reaction. So how we'll eliminate? So if we draw this one in that chair form, so how will we look like this? So it will be look like this. So sorry, my chair is a very bad. So we erase that one. So this iodide is above. So methyl is above. And also you know that elimination reaction will happen at anti-periplanar pathway. So that would be one hydrogen also. So anti-periplanar pathway means whether that or leaving group will be the anti-periplanar to that hydrogen. So there will be two possibilities. This hydrogen also anti-periplanar, this hydrogen also anti-periplanar. So OET minus what will it do? Obstruct this hydrogen and it will come in. So iodide will be removed. By this way, the product will be like this. So this will be double bond. With the methyl is out. So the ultimate product will be looking like this if we are doing like in that form. So the ultimate product will be look like this. On the next one, if we are OET minus, will abstract this hydrogen. This also anti-periplanar. So from this we are getting the product. So here what to do, we have double bond and there will be one methyl is above. So the our product will be look like this. So here will be double bond and here will be methyl. So what type of this reaction is? So this reaction also is stereo selective. Stereo. So from this above three example we are getting that B1 is the stereo specific reaction, but A and C are stereo selective reaction. Stereo selective reaction means where the multiple product are formed. Stereo selective. Like this. And if you use that like this reaction, like where the one is above and another one is below. The methyl, if the methyl is below, then how it will be the product? So methyl is below, then the reaction will be like a stereo specific reaction pathway. How it will be look like this? So I am showing. So methyl, if like that the cases, and here will be our iodide. So any elimination reaction, I have told that E2 reaction, generally that reaction will happen. So that will be, so here the hydrogen is above. So if the hydrogen is above and iodide is above, both are in above the plane. So the OET minus cannot remove this iodide. So from this side, the reaction will be not happen. So from this side, there will be no reaction, but there will be two hydrogen. One is above the plane and one is the below the plane. So this below the plane hydrogen will be react by OET minus. So this will abstract this hydrogen and the double bond will be from here and the iodide will be liberated out. So from here we are getting only one product. So this will be a stereo specific reaction. Now our product will be looking like this. The methyl is below. So this one is an example of stereo specific. So similar, like just to change the position of methyl above and below the plane, we can get that one is would be stereo selective product, two product will from. But when our methyl is the below the plane, there then we got that single product. So this will be an example of stereo specific reaction. So this one I have tell this one is a stereo specific reaction, but this one is a stereo selective reaction. So this one also stereo selective. Yes. And this one is a stereo specific reaction. Now the next example was a bromine and water reaction. So bromine and water reaction, what will from? This bromide is from a three member. So this reaction is going like this way. The bromide first from a intermediate like this. Ethyl. Now the water. So now the water will be attacked from the two sides. There will be possibility of attack. So this one also an example of stereo selective reaction. So water can attack from here and water also attack from this side. But this possibility is better because this there will be one ethyl group, so this will be less possible to attack here. So there will be two products. So this side will be major product, and this side from this side that will be minor product. So what will you get? Product. Ethyl. So will be HBr, and the next one will be like this. So it will be attacked from this side. So this will be OH, and here will be ET. So this is an example of which reaction? Stereoselective reaction. So this one also stereoselective because here the multiple product is formed. Stereoselective reaction. Now we are going to the last example one. So last example one is there will be lithium aluminum hydride is present here. So this and the, I know that any carbonyl or any ester sintered by lithium aluminum hydride we get the product. But if I give the NaBH4 here, this will not reduce that any carboxylic acid center or ester center. So this one is a carbonyl center. This is of course reduced by any LiLH4, also NaBH4. So how the stereoselective or stereospecificity coming into the picture for this reaction? If I draw this one like this way, it will be look like this. So there will be this one carbonyl group, there will be one ethyl group. From this side I have drawing. So from this side if I drawing, so methyl will be right hand and H will be left hand. And all of this group as I keeping it intact, and I have given this as a sign like a square like this. So this will be, if I draw like this, so this will be like, so now that this LiLH4 reaction will happen. So now this LH4 like this, so this will attack this carbonyl center, this aluminium. So this will have oxygen electronegative, there will be metal center. So this will bond like this way, and there will be H4. So then one hydrogen would be attacked into the carbonyl center, hydrate source. If this attack here, this will be become OH. So now this the product will be like this way. So one product will be like this, where so this will be OH. Oh, this one not methyl, this one is ethyl. Sorry, no, no. Oh, this one is methyl. This will be OH. So there will be one H, and below will be this ethyl group. And there is methyl. And long group I have placed like square. So from this reaction, so the product will be looking like this. And if we go to the next route, so where that headed will be attacked from this side. So this will be look like this. So then our product will be so it will be look like this way. So seeing this product, so there will be some ethyl. Just connected this hydrogen. So this will be our next product. So in between, what will be our major product? From this side, this will be major product because this methyl and aluminum, if this side comes, so this will be sterically more hindrance side. So this will be our major product. So this will be our major product, and this will be our minor product. So this will be our major product. So if I draw in this way, it will be looking like this. So from this side, we are trying to reach to getting this molecule. This one is methyl is above, hydrogen is below, H ring is here, and there will be some CH2. This one is also CH2. There will be one methyl group is here, one hydrogen is here, and there will be this carbonyl. This one is hydrogen and this one is methyl, and there will be carbonyl. So carbonyl is become like OH. So from this side, this methyl and carbonyl is same side. So our OH will be same side. So our OH will be in below. So our OH will be below. This ethyl is intact and hydrogen will be the above. So this will be our major product, and the minor product will be look like this. So there is some methyl. This one is hydrogen. So this center have no effect on the stereoselectivity or stereospecificity. But this reaction, this center has the effect. So this methyl is above, H is below. Our carbonyl become. So now this OH will be above, H will be below, and there will be one ethyl group. This will be the minor product. So this one also example of which reaction? Stereoselective reaction. So if we summarize like all of this again. So today's class is what we learn about that some reaction about when there will be some chiral center, then what will happen? So there will be some stereoselectivity and stereospecificity of the reaction. So also we have to find out the stereoselective product and stereospecific product. So what we done? So first we have the know about that what is the stereoselective reaction and what is the stereospecific reaction. The stereoselective reaction are those where the multiple product are formed, but in between one product is major, another one is minor, or like that. And stereospecific reaction, only there will be one product is formed. Only the reactant is stereospecific. Only reactant will attack from one side, not the another side are visible. So like an if I are giving one example, so in this reaction we have to find out this reaction is stereoselective or stereospecific. So we know that any carbonyl center, if we are given a LiAlH4, that is a hydride source, so this will reduce that carbonyl center and our carbonyl center become 2-degree alcohol, like 2-degree alcohol. That is the secondary alcohol we are getting. So any carbonyl center, any hydride source like lithium aluminum hydride or NaBH4, it will attack this carbonyl center, make it as a 2-degree secondary alcohol. And if there will be this one is a aldehyde center or acid center or ester one, so then it will be become a primary alcohol. So this one the carbonyl center. So if we draw this this reaction, this cyclohexane as a chair and board form, because you know any cyclohexane that the conformation are more flexible. The one conformation to another conformation, and the conformation will stable as per the as per our that steric hindrance and all of this or any interaction are present or not. So this the carbonyl center. So now we'll attack the LiLH4 in here. So what will happen? So if the LiLH4 there is a hydride source, so this will be transfer this hydride and this become OH. So it will be like this. So now this OH there will be two possibility. So from that OH will be attacked from the below the plane or hydrate will be attacked from the below the plane and hydrate will be attacked from the above the plane. What will be feasible? So there will be two product. So when the hydrate is above the plane and when the hydrate is attacked from the below the plane and this carbonyl become OH hydrolysis because we are supply water there. So like this carbonyl center, any carbonyl center, and there we are giving ALH4. So O plus Li minus like this, and carbonyl and OLH4. So this will be our hydride. So this hydride will be attack this carbonyl center, and this become ring. This carbonyl become open. So this will be OH. So now the question is this hydride is from above the plane or below the plane. So what will we detect? So if this OH is above the plane and hydride is below the plane, then there will be third butyl group at the fourth position. So this will be one position, this will be fourth position. So fourth position there will be one terbutyl group. So this terbutyl group and OH there will be sterically hindrant group. So if these are sterically hindrant, so there will be steric hindrance in between them. So this conformation are less visible as compared to that in that conformation. So this will be our major product when that tert-butyl and OH are in the opposite. That is one is below and one is the above. So this will be our major product. And I also tell that stereoselective reaction will be like those reaction where we are getting multiple product. So here we are getting multiple product. So this will be our reaction is a stereoselective reaction. I hope you understand. So now the next example one. So this will be the reaction of the dehalogenation reaction. So we have to remove that Br. So any electrophile that will be abstract this bromide and this bromide that electron this single one electron coming here and this bromide also remove. So if we draw this one in that Fisher or Newman projection. So it will be looking like this. So if we confirm that this one is drawing is right or not, so we confirm like this the RS nomenclature, and we have found out that this is the first one where the bromide is the first priority, this one is the second priority, this one third priority, 1, 2, 3, and our four priority is below. So this will be R. So here we are drawing this one. So this one is right or wrong. So this will be our first priority, this second, and this is third. So it will be anti-clockwise, and our four priority is in the horizontal plane. So this will be R. So we have the one this position we have drawn right. Now the next position we have drawn right or wrong. So also we can check by RS nomenclature. Here the first priority is this one is the second priority, and this one is third priority. So first, second, third, it will be clockwise, and our fourth priority is below. So this should be S. So also this should be S as per the above one. So how there is this will be one, this will be two, this will be three, 1, 2, 3. These are clockwise and four priorities horizontally. So this will be we are getting that yes. So we have draw this one is right. Now that any electrophile will attack and this will be going, so the hydrogen are will be in the opposite plane. So for these cases, the hydrogen is below the plane, and this cases the hydrogen will be above the plane. So the hydrogen is below the plane, and 3, the hydrogen is above the plane. So this one is a E or jet. So this one is as a jet butene, because 1, 2, 3, 4, total 4 carbon, that is butene or jet butene. Now if the two bromide are all are in the above the plane or the 2 carbon, then what we get? So we are getting E product. So how this one example is a stereoselective or stereospecific reaction. So this one is an example of stereospecific reaction, because we are getting only one product, not multiple product we are getting from here. So first one example was stereoselective one. So this one is a stereospecific one. Now the next example one. So here also the elimination reaction, and also we know that any that E2 elimination reaction are favored when they are our hydride, and our leaving group will be the anti-periplanar plane. So if they are anti-periplanar plane, then their reaction is feasible. So for these cases, the methyl, and there will be one hydrogen which is below the plane, and iodide is above the plane. So what will happen? This hydrogen will abstract by this ETOH, and our iodide is going out. So we are getting the product like this. The double bond will be from here. So this will be our product. Now the next one. So here also one plane where the anti-periplanar hydrogen are present. So this is the below the plane. So here also the hydrogen will be abstract from here. So now the hydrogen single bond, sigma bond electron coming here. So it become double bond. Hydrogen is leaving out. So now the double bond will be here. So this one is an example of stereoselective reaction. Now if we place this methyl as the below the plane, then what will be the cases? So if the methyl is the below the plane, then hydrogen will be the above the plane. So now the leaving group are not anti-periplanar to this hydrogen one. So from this side the reaction are not feasible. Only one side the reaction is feasible, because there will be two hydrogen, one is above and one below. So this ETOH will be attacked by this hydrogen, and this hydrogen is liberating out. So now we are getting this product. So this will be single, only one product we are getting. So this will be that stereospecific reaction we are getting. So anything that only the position of methyl will detect our product. One of the cases we are getting two product, and one cases we are getting single product. Now the next example. So the bromide and water reaction, we know the bromide and water reaction. So bromide first produced a three-member ring with that double bond. So if these are produced like this, three-member intermediate. So this three-member intermediate, now the possibility of water will be attacked from this side, this ethyl side, or from this side. But if they are attacked from this ethyl side, these are less visible, because this ethyl are in the same to this OH, so this will be less visible. So here also we are getting two product. So OH, ethyl, and BRH. On cases the OH is from this side above the side, and in other cases the OH is from this side. So here also we are getting two product. So this one also is a stereoselective reaction. Now the next example one. So we know that in carbonyl center we are getting that secondary alcohol. So if I draw this like this way, so this will be our carbonyl and this will be our ethyl, and here it is methyl. and hydrogen is this side, and this group I has written like this, a cyclic one. So if this will be the cases, so now we are getting this aluminum hydride. So this will bond like this. Then hydrogen will be attacked into this carbonyl center, and they has become OH. So there will be possibility of from this side also, and from this side also the hydride will be attacked. So we are getting two product, this product and this product. So if I draw in that, from also we are getting like this, and here also we are getting here like this. So this one also an example of stereoselective reaction. So I hope you understand all of this. So thanks. For any doubt, you can contact me. So if we are going to quickly recap it again, so those who are joined last, so this will be our some stereoselective and stereospecific reactions. So stereoselectivity and stereospecificity is arise due to the presence of our that group are above the plane or below the plane, like stereocenter. So, so like stereo-selective reaction, we are getting the multiple product, and stereo-specific reaction, we are getting single product. So this one example, we know any carbonyl center where the aluminum hydride will be attacked, the hydride source, this will become secondary alcohol. This secondary alcohol, so the two product will be from. So when the OH is above and third butyl is above, there will be steric indent. So where this one is a minor product, and this one should be our major product. In the next example one, so now the dehalogenous reaction, our bromide is removed, so we are getting double bond here. So now the for these cases we are getting Z2 butene, but if we are using the product like this, we are getting E butene. This one is example of stereospecific reaction. This one example, so there will be two possibilities. This hydrogen, this OH is minus is attack here. The double bond is from there and iodine is liberated from this side. So the double bond will be like there. And now if we are attacked from this side, OET minus is abstract by this hydrogen, the double bond and iodine is removed. So we are getting this product. But when the cases of methyl is below the plane, then we are getting only one product, because from this side, this hydrogen and this iodide are not antiperiplanar to each other. So these are an example of stereospecific. This one is a stereoselective. So only the position of methyl will detect our product is single product we are getting or multiple product. So this one example, Br2 water. So these are from a cyclic bromine, bromide intermediate first. Then the water will be attacked from this side also and this side also. So we are getting two product here. Now the next example are, we know that carbon center, we are getting from carbon center that secondary alcohol. So this was minus will be attack here. So we are getting two product from this. So this one also an example of stereoselective reaction. So thank you all of this, or even someone not understand the mechanism, they can contact me.